electronics. This is a part 3 of electronic devices and circuits numericals. So we are discussing the questions from electronic devices and circuits, and also we have done a formula revision video of the same. Okay, so let us move on to some more difficult questions in this video. Okay, so the first question is, in the following limiter circuit, an input voltage Vi equal to 10 sine 100 pi t applied. Assume that the diode drop is 0.7, that is these two diodes built-in potential or the drop across the diode is 0.7 when forward biased. Okay, so these diodes are, what type of diodes? They are silicon diodes. Okay, the Zener breakdown voltage is 6.8 volt, that is after 6.8 volt or till 6, that is when 6.8 volt is applied, the Zener diode will undergo breakdown. Okay, so find the maximum and the minimum output voltage. That is, this is the output voltage. We need to find the value of the output voltage maximum and minimum. Okay, so this Vi applied is 10 sine pi t, right? So what will happen? So it is a, what type of wave? It's a sine wave. So a sine wave is being applied. So there is a positive half cycle and a negative half cycle. So what will happen during the positive half cycle of the wave? During the positive half cycle of the wave, this diode D1 will get forward bias, right? And the Zener, if you see, what is the breakdown voltage? It is 6.8 volt, right? But the voltage coming to the input side during the positive half cycle is 10 sine pi, 100 pi t, means it is greater than 6.8, right? So the value coming to the Zener diode is greater than 6.8, so it will undergo breakdown. So the voltage drop will be equal to 6.8 volt across the Zener diode itself also. Okay, and what will happen to D2? D2 will be negative and positive, so it will be reverse bias, so it will act as an open circuit. Now what will be the output voltage during the positive half cycle? The output voltage during the positive half cycle is exactly the voltage on this branch, because this branch will act as an open circuit anyways. Okay, so what is the voltage drop during the forward bias? This diode will act as a simply a voltage source. We have discussed in a lot of earlier videos that during the forward bias condition, the diode will act as a voltage source, and during the reverse bias condition, the diode, normal diodes, will act as open circuit, right? So here, since the diode is forward biased during the positive half cycle, that is D1 is forward biased, it will act as a voltage source. So it will be a 0.7 volt across the diode, normal diode, that is a silicon diode, and and across the Zener diode, it is a 6.8 volt, right? So what is the total voltage of this branch? It is equal to 6.8 plus 0.7. It is equal to 7.5 volt will be the maximum output voltage. Okay, so that is the case. Next, during the negative half cycle, what is happening? During the negative half cycle, D1 will be reverse bias, and this circuit will be now open, and this D2 will get, the D2 will be in the forward bias condition. Okay, so it act as a, this D2 will act as a open, the D2 will act as a voltage cell because it is now forward bias. D1 is making this branch as open. So the voltage drop across this D2 will be equal to 0.7 in turn. Okay, so now during the negative half cycle, the voltage coming to the output side is equal to 0.7 volt is the voltage coming. So this is the case. That is, during the positive half cycle, what is happening? During the positive half cycle, D1 is getting forward bias and D2 is reverse bias. And during the negative half cycle, the reverse will happen. D1 will get reverse bias and D2 will get forward bias. So the voltage maximum is 7.5 volt and the voltage minimum is 0.7 volt. Okay, so this is the answer for this question. We need to find the maximum and the minimum output voltage coming, right? So it is equal to 7.5 volt and 0.7 volt. Question is this: for a BJT, alpha equal to 0.98 and collector base junction reverse bias saturation current ICBO is 0.6 microampere. When BJT connected in common emitter mode and operated in active region with IB equal to 20 microampere, what is IC? So, this is a little bit confusing question. So, we need to find out what all things are being given in the question and how we have to proceed. Okay, we'll start reading from here. When BJT is connected in common emitter mode and operated in active region with IB equal to 20 microampere, what is IC? So we know that the relationship between IC and IB in the active mode of operation of a transistor is given by IC equal to beta times IB, right? So this is a simple relation which a transistor follows in the active region. In active region, what is happening? It acts as an amplifier. The transistors act as amplifiers. That is, output current is IC, input current is IB. So, output current will be the amplified version of your input current. That is, beta times the IB is getting amplified. That is happening in the transistors during the active region. And also it has been given that the transistor is connected in common emitter mode. So in common emitter mode, we know that the current gain is beta. So when you are going for the transistor type of question, you should be familiar with alpha, beta and gamma. Okay, alpha is the common base current gain, beta is the common emitter current gain and gamma is a common collector current gain. So these three factors I have discussed in a lot of my previous videos. So please watch any of those videos from analog electronics or EDC itself. You can find the relationship. And also in the formula revision video also I have discussed about alpha, beta and gamma. So you might be knowing this. This is very simple. Okay. Now what is being given in the question? So this is the relationship we have to go for because we need to find IC. We have been given IB. But again, something else is also being given. For a BJT, alpha is 0.98. That is common base current gain alpha is equal to 0.98. We have not been given the value of beta. We have only been given the value of alpha. Now, what is the relationship between beta and alpha? Beta is equal to alpha by 1 minus alpha. Okay. So, alpha is 0.98 by 1 minus 0.98. Okay. If you solve it, you will get the value of beta as 49. The value of beta is 49. Okay. So, we have obtained the value of beta now. Beta is equal to 49. Now, one more thing has been given that the collector base junction reverse bias saturation current ICBO is 0.6 microampere. Now, if this ICBO was not given in the question, you can directly go for the relationship. That is, with this time, that is, since you have beta, now you can find the value of IC. But they have been given the value of ICBO, that is collector base junction reverse bias saturation current also. So that is an indication that you have to take into consideration the reverse bias saturation current also while finding IC. So the equation for IC will now get modified as beta times IB plus the reverse bias saturation current of collector to emitter junction. Okay, that is beta IC equal to beta IB plus ICEO, which is the collector to emitter reverse bias saturation current. Now, what is the relationship between ICEO and ICBO? Relationship between ICEO and ICBO. ICEO, that is collector to emitter reverse bias saturation current, is equal to 1 plus beta into ICBO. Now, directly we have beta also, ICBO also. So, we can find the value of ICEO, right? So, 1 plus 49 into 6 microampere. Sorry, 0.6 microampere. So, it will be equal to 30 microampere you will be getting as a value. So, ICEO equal to 30 microampere. Now, all the values we have beta, we have IB, we have ICEO. So, we can find the value of IC. So, while considering such type of questions, you have to think whether you have to take the the reverse bias saturation current or not. If it is not given in the question specifically, you can directly go for, that is without considering the minority current or the reverse, that is a reverse bias saturation current. You don't have to consider in some cases. So directly you can go for the relationship that IC equal to beta times IB. But here, since it is specifically given in the question, you have to take into consideration of the ICEO also. Okay. Beta is 49 into IB is 20 microampere plus ICEO obtained was 30 microampere. Right. So if you solve it, you will get the value of 1.01 milliampere is the value of your collector current IC. Okay. So the correct answer is option D, 1.01 milliampere is your correct answer. The next question is this. The Zener diode in the regulator circuit has a Zener voltage of 5.8 volt and a Zener knee current of 0.5 milliampere. The maximum load current drawn from this circuit during the proper working with voltage range 20 to 30 volt. So we need to find the value of maximum load current. The load is at this side and there is a resistor of 1K or 100 ohms and a Zener diode connected. So this Zener diode is acting as a voltage regulator. This is a regulator circuit. Okay, so what will be the total current in this circuit? It will be equal to the current flowing through this 1K or 1000 ohm, right? Also, we need to find the value of maximum load current, and this maximum load current is generated when the voltage input applied is maximum. So the voltage range is from 20 to 30 volt. That is maximum voltage here is Vmax is 30 volt is the maximum voltage, right? So we need to find the value of maximum current, maximum load current. So for that we apply the input as 30 volt. Okay, so the total current in the circuit we can equate with total current equal to load current plus Zener knee current. That is the reverse current during the reverse bias current of the Zener is called Zener knee current. So it is equal to, I am representing as IZ. So we don't have the value of IL, but we have the value of IZ, which is 0.5 milliampere. Right. Now what will be the total current in the circuit? It will be equal to the current flowing through this 1000 ohm. So what will be that? The voltage difference by 1000. The total voltage across the 1000 ohm or the 1K is 30 minus the voltage across the Zener diode, that is 5.8 volt by 1K. Right. It will be equal to 30 minus 5.8 will be equal to 24.2, right? 24.2 by 1K, that is 24.2 milliampere equal to IL plus 0.5. So IL equal to 24.2 minus 0.5 milliampere is equal to 23.7 milliampere. Right? Okay. I hope you can't see if I write here. I'll write it once again. So this is the equation. 24.2 you will get 24.2 milliampere you will get if you find the total current across the 1K or the 1000 ohm. Okay, I'll write it as 1K. So it will be 24.2. So you can equate it with IL plus 0.5 milliampere. Okay, so from that you can find IL as 24.2 minus 0.5. So it is equal to 24.2 minus 0.5. It is equal to 23.7 milliampere. So the correct answer here is option A is your correct answer, which is 23.7 milliampere. The next question is a match the following type of question. That is, you have to match the items on list 1 with list 2. So the list 1 consists of certain electronic devices like NPN transistor, silicon control rectifier, FET and MOSFET. And you have to match the list 2 with their symbols. Very simple, but you have to apply some tricks to solve it very faster. Okay, so let us start with the first name, NPN transistor. So we have to look for the symbol of the NPN transistor. Sometimes you may get confused, right? So how to apply a trick, how to solve it very faster. We know that an NPN transistor consists of 3 terminals, emitter, base and collector, and they are represented as E, B and C, right? So from this list 2, we have to look for the the symbol which consists of emitter, base and collector, rather than just going for the symbols icon or just the direction. Just look for the value or the names or E, B and C. For this we have to look for. So for the first figure, we cannot find any E, B and C, right? So this is not a NPN transistor. Also, for the third figure, there is A, G and C. It is not E, B, C. Also, for the last figure, it is G, D and S. So it is not again NPN transistor. Your correct answer is option B, or the second one is your emitter, base and collector. And also for NPN transistor, the arrow is towards inside. You don't have to think about the arrow, the connection and all. Just look for the terminals first. If you could not find out from the terminals, then go for the symbol. So don't confuse it from the beginning. Just first start simple. Okay, so emitter, base, collector is only found in the second figure. So the correct answer is second figure is your match. Next one. Silicon controlled rectifier. In silicon controlled rectifier, there are three terminals: anode, cathode and a gate. So this is a silicon controlled rectifier, right? So where can you find anode, cathode and gate? In the third figure, there is a anode, there is a cathode and a gate terminal. So the correct answer is the third figure is the silicon controlled rectifier. Now only there are two options left. So FET, field effect transistor, is a simple type of the FET, and this field effect transistor consists of what all terminals? Gate, drain and source, GDS. Where can you find the GDS? It is GDS. This is that is the last figure is your field effect transistor, and only one option is left, that is MOSFET. For the MOSFET, it will be your first figure itself. Anyway, there is no other figure, so it will be your correct answer. So MOSFET is metal oxide semiconductor field effect transistor. So it consists of gate, drain, source and a substrate or a body. So it is a B. So that is your correct answer. So this is your match. Okay, so this is how you can find out the symbols. So in questions, there will be symbols, there will be names and you have to match, and they will be giving various options for the match. You have to find out which correct option give you the exact match. Okay, so this is how you can find out the symbols very fast rather than just going for the diagram, arrows or anything. First go for the terminals. What are the terminals present in the device? Then find out from the terminals. Then choose a correct option. If you could not find out from the terminals, you have to then think about the symbol, the arrow and everything. Okay, so this is the correct answer for this question. And these are the questions which I have included in this video. We'll be doing more videos on electronic devices and circuits. We have uploaded 3 videos for numericals and 1 video for the formula revision. So I hope that these videos was useful for your preparation. If you're preparing for any of the exams, there's a lot of exams going to happen. DMRC, GATE, BARC and a lot of exams is coming. I hope that these videos will be useful for your preparation. If yes, please do give it a thumbs up and also share this video with all your friends who's preparing for the examination. And if you want more videos, please do subscribe to the channel. Thank you.